All right. Welcome everyone to the Mega Alumni Podcast. Today we have our next guest, Dr. Kelsey Shaler. And before we get into the episode, just a brief introduction about Mega and the host. So Mega is the graduate student organization at The Ohio State University, the Mechanical, Aerospace, and Nuclear Engineering Department. And this alumni podcast is just our mission to hopefully connect our current grad students and maybe even undergrad students with alumni from our department. And my name is Nehal. I'm a PhD candidate here in the department. Today, I'm also joined with a new mega member who is going to be co-hosting this episode with me. Julia, would you like to introduce yourself?
Yeah, hi. My name's Julia Taylor. I'm happy to um, be involved in Mega. This is my first semester as an aerospace engineering PhD student, so very happy to be here and joined by our guest.
All right. So without further ado, let's get started with the episode. Dr. Kelsey Shaler, thank you for joining us for this episode. Can you give us a brief introduction and some background about yourself, what you did kind of at OSU and what you're doing right now, to get us
Yeah,
started?
I'm Kelsey Shaler. When I was at Ohio State, I do wind turbine research. And so I did that at OSU as well. I actually started in a group doing high fidelity CFD of backwards facing airfoils. And I actually changed focuses after that to be on kind of more mid-fidelity modeling of wind turbines and wind turbine wakes. And my focus was on um, um, turbine wake interaction. So how the wakes of turbines impact the loading of downstream turbines. And so did, yeah, some coding and analysis in that space. And then after grad school, went to NREL, the National Renewable Energy Lab, and did really similar stuff there. So still turbine wake interactions at NREL. Did a postdoc there. Was there for 4.5 years, and then after that, so now I'm at Shell, where I still do similar stuff. So it's still all wind energy research. Um, Turbine wake interactions is still kind of my main interest. And so different kinds of wake modeling, different kinds of turbine modeling, how the turbine lifetime and fatigue and stuff are impacted by turbine wake interactions. Lots of other stuff, but that's kind of the main my main focus is, yeah, in that space. So from grad school up until now, that's what I've been doing.
So is there any, I know we spoke a little bit earlier about that you can't exactly talk about the specifics of what you're doing. To what extent could you tell us about what kind of work you're doing at Shell right now
Yeah.
in a
So
broad sense? Yeah.
yeah, so still a lot of research. So the way that our kind of the team is set up at Shell is there's a business team that handles bids on wind farms and like actual designs of layouts and financing and all that stuff. And then there's the research team, and that's the team that I'm on. And so the research team, what we do is um, anything to support the business, really. So sometimes that's higher fidelity modeling. So if they want, wake modeling, but maybe they're not set up to do CFD, we'll do CFD runs for them, or, higher fidelity loads modeling, or just kind of if they're like, hey, this is something we've seen where maybe we can improve our bids in this aspect, we can look at it and say, okay, we can do these higher fidelity modeling or whatever to kind of improve the bids. We do a lot of work with external partners, so collaborating with academia, national labs, even other industry will be kind of on projects together. So and attending conferences and all that research stuff also. So it's, yeah, still research, but very much focused on how can we help the business is kind of the bottom line.
Great. For some of our viewers or for people who aren't quite familiar with offshore wind energy, could you go into maybe why that would be a feasible option or like challenges and benefits to setting up these wind farms offshore?
Yeah, so onshore has been around for a long time, right? And offshore is newer, especially in the US. It's definitely a lot more established in Europe. It's a lot newer in the US. And the benefits of offshore are the wind speeds. So the wind speeds are a lot higher offshore. So you can build um, larger turbines, higher wind speeds, so you basically get more bang for your buck when you go offshore. The challenges of offshore are there's a lot. Transmission is a big one. So how do you get the power from offshore? You have to think a lot about, fishing, how it impacts fishing and wildlife, which is the onshore is the same. Like onshore has a lot of those same challenges. It's just the fact that it's so new that offshore is challenging. The turbine installation is a lot harder. There's a lot more logistics. So you can't just have folks drive a truck out and put up a truck or put up a turbine and you have to um, charter a boat, have the boats go out, install them offshore. The weather's a lot more important. If there's really bad waves, if there's bad weather, then you can't do it. So there's a lot more seasonality to installing
Mm.
offshore wind farms. And there's just a lot more regulations too, or maybe harder to get around regulations. So yeah, there's a lot. There's a lot of why it's challenging. But the payoff is a lot higher. So again, it's a lot more bang for your buck. So the wind speeds are so much higher that's why it's very attractive to do it, despite kind of the challenges that go along with it.
Yeah.
And from a modeling perspective, it's harder too because it's not just the wind, it's the waves. So you have to model a lot more things. There's the waves, the current, and everything. So you have to model a lot more things from a modeling perspective. So as a researcher, that's fun. It's more challenging, which is fun, but yeah, practically it is challenging.
100%. I can imagine, I can totally imagine that, and just the issues that you kind of raised. Yeah, like those are hard engineering challenges. And you mentioned one thing, which is what I was also thinking about when I was just looking up the this kind of research. And so I'm curious, so is when you're looking at offshore, are you also potentially looking at ways of combining the wind and the energy you could get from waves, so some sort of tidal energy systems or something like that, and
Yeah,
couple them together, since you are kind of going offshore and you're putting so many resources out there.
yeah, there's
Uh,
definitely some work and some kind of um, research scale sites that look at combining. I mean, I think this is true for renewables in general, but combining renewables, there's not just one answer, right? And so combining wind and solar, there's research into tidal converters or wave converters. But yeah, kind of coming up with energy islands is what
mm,
they're called when they're offshore. Is kind of combining all of these um, technologies into one space, so that if you're building a bunch of stuff offshore, you might as well put more out there, so you get again more return on investment, kind of bang for your buck. So yeah, that's definitely I would say still in the research side of things. But yeah, that's definitely something that a lot of people are looking into. It's a very interesting kind of space. Yep, for sure.
right. So I guess the other question I had was, and I know since you can't maybe go into specifics about how you're doing modeling at Shell, but you mentioned that before that you had a brief period where you're working at NREL and doing some modeling in the same area over there as well. So I was wondering if, so is your broad kind of area just focused on numerical modeling, and or are you looking at some side of the experimental stuff right now too, in terms of actual turbines being deployed or something like that?
Yeah, so yeah, I only do computational work. I'm not an experimentalist. at all. I think I did one internship with experiments and that was it. So yeah, I just do the modeling, but there's definitely a lot of work, kind of no matter where you are and whatever space you're in, or whatever kind of codes you're using. Validation is one of the most important things that you can do because even, a lot of people are like, oh, CFD, it's the truth solution. Well, no, if it's, just because it's higher fidelity doesn't mean it's right. So whatever you're using, validation is one of the most important things you can do. So there's definitely a lot of space. I did a lot of validation work when I was at NREL. It's definitely something that kind of everyone in research continues to do is validation. So there's definitely always work with experimentalists, with the experimental data to compare it to the computational results. So that's something that even codes that have been around for a really long time, they're just continuously being reevaluated for new situations. So also a code that's been validated for onshore, you also need to validate it for offshore. If it's fixed bottom, you have to validate it for floating. Like there's all these different, maybe just the, wind and waves kind of combining everything. There's all these different elements that go into modeling wind turbines. And so all those areas are, so it's definitely a very important part of what I did at NREL, I'll still continue to do.
Awesome. So I suppose speaking more about your experience at NREL, so how is your research expectations or the research expectations different from your current company or industry to a national laboratory, or kind of those difference and nuances
Yeah.
in your experience?
So yeah, still being in research, obviously if you're on the business side, it's a very different situation, but just talking in terms of the research, I think still do a lot of the same things are still important, like things that, we look a lot at the research that comes out of NREL, we collaborate with NREL, or, other national labs and academia. Everyone is kind of aware of what the big problems are and is trying to solve these problems. And so being on the industry side now, the focus is just maybe a bit more on having a business case for it. So you can't just do something, because I don't want to say just because it's cool, but there's some, things that get done where it's like, this is important, but is there a direct business case for it now? Maybe not. And so that's something that like a national lab would do, or, in academia, it's more fundamental science. Whereas in industry, it's, it really is there a business case for this? Is this going to improve an actual business model? And if it's not, sometimes you can still do it, but it's a bit more hard of a sell of like, hey, we really should, you got to really fight for it. But if there's a clear business case, then, that's kind of the main focus. So I would say, yeah, it's just more of having the motivation is maybe a little different and more focused. But a lot of it is the same, we all know what the problems are.
Gotcha. Yeah, since you kind of even brought up the
Actually, wait, I'll just add really quickly too, or part of it also is funding other places to do the research, right? So a lot of industry will work with national labs, will work with academia to say, hey, this is a problem. We don't have the expertise, or we don't have the time to solve this. Can you solve it for us, or can you work on this? And so that's another focus, is still working with the national labs and academia, but in more of a kind of supportive, aspect of you do the research and we'll just kind of guide the motivation. So that's a difference too.
Gotcha.
Makes sense. And I guess that was kind of tying into what I was going to ask next. So as you mentioned that now over the years, I guess you have had maybe some more role to play in terms of like a supervisory role of like you have more experience in knowing what the problems are. And so you are deciding or figuring out where the money should also go and maybe sponsor people who are trying to solve those problems in new and innovative ways. I'm wondering when you were at NREL, and I saw that you had this designation change in between. So I'm wondering if there was any opportunity while you were even there, uh, to seek out some funding yourself, as a researcher, or were you always working as a part of the team and there was someone else who was maybe a lot more experienced and they were the one who were getting the funding and maybe they were deciding how and where the money goes, or like did you have some opportunity to get into that even in the national lab?
Yeah, so well, I'll say it's always a team, no matter what. There's always, even if you're not the PI, or even if you are the PI, there's always a team. There's always lots of people involved in, you know, programs and projects and getting funding and that sort of thing. So yeah, I tended to be more of not necessarily writing the proposals, but more doing the work. We did, me and actually he's a coworker at Shell with me now, but we did, it was called Energy I-Core, where we wrote a proposal and got funding to do, we kind of came up with like a pseudo company, like a fake business model, and did some work there to kind of explore how could we make this a viable business. So that was something that I did when I was at NREL, where yeah, kind of wrote a proposal, got funding for that. But yeah, aside from that, it was more either supporting proposals or doing the work, not really like writing them from scratch myself.
Got it. I actually had a very quick follow-up. Since you brought up like the whole idea of, making up some sort of an idea or a fictitious company to validate some sort of a business model. And when you're working with some kind of a technology like this where there is a lot of work that needs to be done. And when you're talking about business, you're always talking about, okay, how quickly. I remember we had an entrepreneur come up here a couple of episodes back, and they were talking about, how setting up engineering based companies can involve a lot of work, especially if the technology is like new and you don't know how to get the word out there. So if you're talking about like money coming in, for a technology, very new technology like this, where you don't know how exactly it is going to make money right away, how do you think about the business structure or the business plan as a whole? I'm curious if there is an
I
answer
don't
to
think I'm
that.
the right person to ask
Okay,
about this. I am not actually an entrepreneur. So I don't think I'm the right person to ask this
got
question
it, got it,
to.
got it, got it, got it.
I mean, I could say some stuff, but it's just not, I'm not an expert on that.
Gotcha, gotcha.
So I suppose when you're talking about your experience as being more of the doer or the um, doing the execution of these things, your modeling tools, were they in-house that your team was developing, or did you utilize different commercial codes, or where did you kind of pull your resources?
So at NREL, it's all in-house. Well, I shouldn't say all. A lot of what the team does at NREL is develop open source modeling that's then used both by researchers at NREL, and in academia and in industry as well. So at NREL, it was what I did was develop, and use in-house open source tools. I'd say at Shell, it's a mix. Um, there's some in-house, some commercial, some open source. It's very much a mix, and different, you know, groups use different things. So it's definitely a mix.
Mhm.
Gotcha. I had a follow-up question on, I think, one of the terminology that you kind of specifically used, just a few minutes back. And I think I had a somewhat of a brief discussion with our last guest on this as well. I don't know, you might have crossed paths with him, Dr. Unni Krishnan. He was the
Oh
last
yeah,
guest. He was
yeah.
the
My first group, we're actually in a group together.
so he
Yeah.
was the last guest, and he's currently a faculty at FAMU FSU, and he was we were talking a little bit about high fidelity and what a high fidelity model means, and you brought up this idea of mid-fidelity, which I
Mm,
don't think I've heard that word that often. So
mm.
I'm a little curious what you mean by that. And yeah, how is it different from high fidelity? And is there a low fidelity model as well that
Yes,
is
and I'll
important?
say
Okay.
yes, and I'll say that this some of these designations are a matter of perspective. So if you talk from someone who primarily does high fidelity, they're going to have a certain definition of low, mid, high. And if you talk to someone who, does, I don't know, Excel spreadsheets or, like really simple
Right.
models, they're going to have a different opinion. So some of that is relative. So mid fidelity, and I'll say as someone who started in and still does high fidelity, I would say, high fidelity is like CFD, um, LES. RANS is like kind of lower mid fidelity or lower high fidelity, like it's high fidelity, but it's faster. And then so the mid fidelity codes that I use, they're I don't know, I guess they're called engineering models. So they're still dynamic. And I'm thinking of a couple. So there's for wake modeling, there's one called free vortex wake modeling, which is primarily what I did in grad school. And then there's also dynamic wake meandering, which is faster. This is where it gets tricky. It's a lot faster than free vortex wake modeling, but I wouldn't call it low fidelity, and I wouldn't call free vortex wake modeling high fidelity.
Hmm.
If you talk to someone who does steady state, they would probably say that free vortex wake modeling is high fidelity. So
Right.
there's a range there. But yeah, so when I say mid fidelity, I mean, yeah, dynamic wake meandering or free vortex wake modeling. And yeah, the way you kind of define it is, yeah, it's kind of what are you used to? So like someone who does LES would say dynamic wake meandering is low fidelity, right?
Right.
So
Right. 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 Right.
is that your question?
Yeah, no, that definitely does. And I'm also somebody who does computational work. I work with Dr. Sandeep Mazumdar. Uh,
Oh, okay.
so my work is also all computational, which is why the question
Yeah,
came up
yeah.
into my mind. But that definitely answers it. And yeah, interesting to know the perspective that you have on it.
Yeah, and I'll say too, one of the fun things with wind turbine and wind farm modeling is that there's so many there's so you have to model the turbine, the wind, the waves, kind of all of these different pieces that work together. And so you can have, and those are all modeled not separately, but like, there's a structural model, there's a wake model, there's a flow model. And so you can have different levels of fidelity for all those different models within one code. So you can have a high fidelity wake model, but a low fidelity structural model or vice versa. And so there's a lot of when you're talking about modeling these systems and the different codes that you're using, even within just one simulation, there can be different ranges of fidelities depending on what aspect of the system you're looking at.
Right, right. There's I guess that aspect of modularity that comes into like use better equations just for this part, use
Yeah,
slightly simpler
yeah,
equations for this part kind of a
yeah.
thing,
What
right? So,
what's the focus? What are we looking? Do we need
right.
to get a lower fidelity model for this so that it runs faster? Like what's kind of the balance there?
Right.
Yeah.
Yeah, I guess I have some follow-up questions on like just how you're modeling some of the so I think a lot of the work that you're doing and the keywords you're talking about is wake modeling. Uh I'm curious how the wakes are very important for wind turbines, and to what fidelity do you need to model them to actually understand how much energy they are going to capture from the wind
Yeah.
very
Um,
accurately. Yeah.
so it all depends. Um, so if you are, let's see, you asked a couple questions and they all kind of have their own answer. So wait, can you restate your questions? My brain is still not
No,
100%.
no problem, no problem. Yeah, I guess the main idea was that since you're working on understanding the wake structure on the turbine,
Oh,
uh,
that's what, yeah, yeah, yeah. Okay, that's what your
yeah,
question. Thank you.
yeah, yeah,
Um, So the wakes are important. The wakes are very important. I would say they're the most important. So the thing with wakes is that um, they impact the downstream turbines. So a turbine wake, it has reduced mean wind speed and increased turbulence intensity. And so what that means is if that wake is impacting downstream, is hitting downstream turbines, you're going to have lower power because the wind speed is reduced. So that obviously has a big impact on AEP, which is annual energy production, which is kind of the main thing that's measured with wind farms is what's your AEP. And so if you have lots of interactions between turbines, you're going to have lower AEP. And also with the increased turbulence intensity, something that happens is you have higher fatigue loads on your downstream turbines, which could impact the lifetime of your turbines. So those are kind of the two main considerations. So then when you're doing, layout design or something like that, you have to consider, okay, well, I don't want my turbines to interact too much because of these negative things that might happen. But also, the more densely I space my turbines, the more power I'm going to get. And so it's always this trade-off of power versus, lifetime, or making sure your turbines aren't, maybe you'll put in 100 turbines, but if they're too close together, you might as well have built fewer turbines and spaced them out more. So that's a lot of what goes into kind of planning a wind farm. In terms of modeling them to capture those interactions, again, it kind of depends on what you're looking to get out of that. So if your main focus is AEP, if you only care about power, steady state tends to be fine. So you can do, and which is what people do is, so like there's an open source code developed in NREL called Florus, which is a steady state model. And you can do really quick AEP calculations for wind farms. So you can use it for optimizations and that sort of thing. And so, yeah, so when you're just looking at power, steady state models tend to be fine. When you're looking at AEP, when you're looking at kind of big picture over a course of a year, what are we looking for? Those models tend to be fine. Okay. If you're looking for, I have a really specific atmospheric condition. So if you have like low level jets or like an atmospheric condition that happens in certain parts of the world where normally your wind profile, if this is your ground, your wind profile goes like that. And your turbine hub is somewhere around here. If you have a low level jet, it kind of looks like that, where the peak wind speed is lower to the ground. And that has implications for power, but also for loading. So anyways, if you're looking at really specific atmospheric conditions like that, then you would need higher fidelity wake modeling, atmospheric modeling to capture those, those situations, those mechanics. If you're looking at fatigue loading or ultimate loads, which is what I tend to look at, you need dynamic models. Steady state models, just by definition, will not give you anything that you're looking for. So if you're looking at fatigue loading and ultimate loading, you need dynamic modeling. And within that, there's a lot of levels also. So like dynamic, I was saying before, like there's dynamic wake meandering, there's free vortex wake modeling. Which of those do you need? It kind of depends on what level of granularity you're looking at, kind of how important, are you looking for an exact answer? Are you looking at trends? That also matters in terms of what fidelity you need. Different components of the turbine require different fidelities sometimes. Are you doing, onshore, offshore, fixed bottom, floating? It all kind of depends. And so, yeah, in terms of fidelity, again, it depends on what you're looking for.
Got it. Got it. Yeah, I realized as you started answering that question had obviously a lot more nuance and there's a lot going on. So thank you for sharing.
Yeah. And I could talk way more about that.
We can circle back to it definitely if we have some more time. I'm open to it. Do you want to take the next one, Julian? I've been hogging up all the time. Sorry.
Yeah. Sure. So I suppose shifting the conversation to more of your time at OSU. So how did your research background kind of set you up for your experience graduation? I guess were there
Yeah.
challenges or benefits to that change
Yeah.
in perspective?
Yeah. So the research that I did at OSU very directly translated into my work at NREL. So when I was, you know, at OSU, when I was doing the turbine work, I used NREL codes, used and modified turbine or NREL codes. And so that was a really applicable skill when applying for a job at NREL. And, I think this is true for everyone, but presenting at conferences and kind of doing that networking at conferences is, the most important thing, I think, in terms of getting a job kind of after your graduate work. So I, did research, I presented my research at conferences, made, connections with folks at NREL. So, they knew about my research, they knew I knew about them, they knew I was interested in, positions with them, that sort of thing. And so, and I got hired as a postdoc to do pretty very applicable what I had done in grad school. It wasn't the exact code. It was a different version of the same code. So it was very, very directly applicable for the work that I was doing at NREL. I did turbine wake interactions in grad school. I did turbine wake interactions at NREL. It was all, very, very applicable. So, which was part of my intent. I wanted to work at NREL for a very long time, and so that was intentional.
So I think it's safe to say that you have enjoyed your research and where it's led you so far.
Yes.
That's great to hear. And yeah, and since you mentioned that you kind of already always had that goal in mind of going to NREL, I'm wondering, like, did you have some idea that at some point, I'm guessing you did not like the experimental side of things because you said that you did one internship, and so you decided to do computational work. But with, like, I'm also a computational person, hence this question specifically. How do you kind of narrow down on the application area, or like what am I going to model? Where the money lies, and that can sometimes be a little tricky.
Yeah.
So how windsure and how did you land into that? Uh, or was
Yeah.
it kind of just fate?
So I've always been into wind. I did a project on wind when I was in fifth grade, and I was like, this is awesome. So, I've always kind of had that in the back of my mind if I want to work on renewable energy. When I was in undergrad, so I'm mechanical engineering. I guess I never said that. I'm a mechanical engineer. All of my degrees are mechanical engineering. So I took fluids and I took, mechanics, structures. I took kind of all that stuff. And I always just really liked all my fluids classes. Like, I just thought they were so fun. I loved them. And then the first coding language I learned was Fortran, which
Yeah.
also has set me up for my research career, because that's not a skill that a lot of people have. So the codes that I worked on at NREL were all in Fortran. And so it was like, oh, not a lot of people know Fortran. So anyway, I liked all my fluids classes. Then I took a coding course in undergrad, and I was like, oh, I love coding. And so then I learned about CFD and was like, well, this is just really cool. I mean, it's just cool. Looking at the animations of all this modeling and all the things you can simulate, like, I just thought it was amazing. And so that's what I wanted to do in grad school was CFD. And I did that. I started with that. And I still do CFD modeling. So I think it just kind of happened. It was just kind of my interest. And then with wind, I think kind of whatever you're into is applicable for wind. There's so many different aspects of it. So like there's a lot of like electrical engineering work, structures, that sort of thing. But I think, so now what I do is kind of how wake modeling impacts structural modeling. And I think that comes from my mechanical engineering background. So because I have a strong background both in fluids and structures. And so I know you're Aero. I'm not dissing Aero, but I'm just saying, I had all those courses. I also had an interest in structures. And so I think kind of having that background, it was maybe easier for me, or more natural, to kind of do that focus area of fluids and structures. Yeah, so it just kind of happened.
Gotcha.
That's really cool. So, I mean, you've kind of already answered this question, but we've also had NASA internships, and undergrad research experience. So, I guess, did any of that impact what you wanted to cover during grad school, or was it kind of just that natural flow of like everything kind of compiled to where you are or where you went?
So I don't know that it impacted the research that I went into, because the stuff that I did for those NASA internships didn't really, I mean, one of them was experimental, obviously didn't translate. The last two were computational, but it wasn't really very different area. So I wouldn't say that the research itself necessarily translated, but it got me excited to do research. So it kind of solidified that I wanted to get my PhD. Um, and it also made me really like national labs. So yeah, I have a lot of experience at national labs, and I really, really enjoyed working in that atmosphere. So I would say it more impacted, getting my PhD and kind of at least initially going into that national lab space. Was probably the most impactful. I will say, if you have an opportunity to do an internship with NASA, I absolutely loved it. It was amazing, really phenomenal. So yeah, definitely a good start to research.
For sure.
That's pretty good to hear. And so, since you kind of touched upon this a little bit too, do you think there's some commonality in how research is conducted in these national labs, which is why you found it to be really fun, as a starting point?
I think, well, all the national labs are really different in terms of what I'll say, so I had internships at NASA. I also had an internship at the Army Research Lab, and then, yeah, worked at NREL for several years. So like, there's very different research that happens. I think some of those places, some folks do more fundamental research. I think the thing with national labs is it's a nice kind of in between academia and industry. So, right, academia, and this is broad generalizations, but academia tends to be a little more fundamental science, which is not really my jam. And I didn't think I ever wanted to go into industry. So I was like, I'm not interested in that lifestyle. So national labs are kind of a nice in between of, you're still doing research. I liked that it was all open source, that sort of stuff. But it's a lot more applicable. You're working for companies a lot of the times. So it's just kind of a nice in between. And I don't know, the vibe at national labs is really good. Like, people tend to be pretty chill and like, just less intense. I don't know if that's the right way to say it, but the atmosphere I found to be really nice.
Gotcha.
So, plug for national labs.
Yeah, 100%, 100%. And I guess that somewhat ties into the question that I was thinking about in terms of just general work culture. I know you talked about your grad school experience a little bit when we were talking via email. So I was wondering if there is something, and since now you're working with a team and you're probably leading them to some extent since you're more experienced, I was wondering if you have any thoughts on, just going just about setting up work culture and navigating conflict when you're working with people and dealing with that, and if you're in grad school, if you want to navigate with any kind of conflict, with peers or within the lab, if you had any ideas, anything that you want to share from your experience, I'm sure everyone would be happy to listen.
Yeah, I think in terms of navigating conflict or disagreements or whatever, I think, and I'll skew this a bit towards grad school. I think having boundaries is incredibly important. And I think a lot of times there's pressure to not have boundaries, and to just kind of let superiors dictate everything that happens. And, if, destroy yourself to meet these standards and these timelines and criteria of other people, regardless of how it affects you as a person. And I think that's not okay. So I think, and I wish that, I knew then what I know now. But upholding boundaries is very good. If someone will not let you uphold a boundary, that's something that they need to work on. And you should bring that up to other people who are there to help you and protect you. So don't feel like you should sacrifice, unless your boundary is like, I'm not going to show up to work before noon. That's a bit of a different situation. But don't feel pressured to give up on your boundaries. If someone wants to violate that, that's something they need to work on. And standing up for yourself, I think, especially as a grad student, can be challenging. I think a lot of times people will say like, oh, we're here to help, or, but it doesn't always feel that way. It doesn't always, it kind of feels like this one person has all this power and you can't go against them and you can't say anything, or, it feels that way. I very much know that to be true. But it's not. There are, people who can help. And if something's not working, if something doesn't feel right, if you don't feel good, don't just go along with it. I know it's a lot easier said than done, but really, it doesn't have to be that way. So that's my spiel on doing that for grad students, especially. And I think that carries over into work as well. Establishing boundaries is important at all points in your career with everybody. So I think that's the most important thing is, establish boundaries, know your self-worth. Don't let someone, dictate how you feel about yourself.
100%. That makes a lot of sense. And if you had anything extra to share based on like the being in an industrial setup now and maybe working with a team, and I know this is maybe coming into like all of us grad students together working in Mega, this is also all kind of volunteer work, but sometimes it can be an ask on our times as well. And so we're always figuring out this balance and figuring out what boundaries are good for us, good for growth, but at the same time, like not completely exhausting us. So if you had any strategies of like how you uh, set up some things in your environment at work that help you kind of find this enigmatic work-life balance that everybody is seeking.
Yeah. So, first I'll say this is always a work in progress, and there's, I definitely have lots of things that I still need to work on. I think being strict on your schedule is probably the most important thing, at least for me. And I think it's also the hardest thing to do. But really knowing what's good for you and what's not. So being on your email until 10 p.m. at night, I know some people who that's totally fine for them. Personally, that doesn't work for me. And so I think setting those schedule boundaries is really important. Blocking out time, especially as you get like into the work, like out of grad school into the workforce, man, meetings just consume everything. And so I like to block off like focus time. So I'm like, okay, I won't take any meetings during this time. This is time for me to actually focus and get my work done. So setting those, kind of boundaries is really important. And I think just, realizing what helps you be the best you. So, for me, it's like exercise and sleep and eating, which are really hard things to maintain when you're like, you know, you want to do your best with all these things going on. Like it is so hard. And I am not like a spokesperson for being great at work-life balance. Like I have a lot, you know, it's really hard. It's really hard. But I think just really prioritizing those things because, you know, I've noticed a lot where I'll be working and I'll work until like 10 o'clock and it's like, okay, if I just need to get this one thing done, and then I can stop. And it keeps creeping and creeping and creeping, and you never get the one thing done that you really needed to get done. And then you go to sleep and you wake up the next morning and you're like, that was all wrong. And if I had just stopped working at 6 o'clock and taken a break, like I just wasted all of this time because I was tired and exhausted and I didn't eat and I was cranky. And so just, I think just recognizing you're not doing yourself or your work any favors by stressing yourself out and overworking yourself and doing all of these things. Like taking care of yourself, you'll do better. um, and just, yeah, that's a really, really hard life lesson to learn. And just keep trying and doing it and just know how important it is. And if you can, have supervisors and managers and everything who support that. You know, who support that work-life balance. So, you know, having people who expect you to answer email at 10 p.m., that doesn't work for me personally. You know, so setting those expectations with superiors and the team and, you know, being clear on this is when I'm working, this is when I'm not working is very important.
Absolutely.
So.
Julia, did you have anything else that you wanted to ask? I think we covered a lot of the things that we discussed before, but did you have anything else based on the research topics that Dr. Shaler was talking about?
Hmm. I don't think I have anything additional. I mean, I asked the question of, why offshore wind energy. So I'm not very familiar with, the sustainable energy area. A lot of my work is like in the modeling of energy that we already have, and not necessarily sustainable. But yeah, it's been really, really interesting to learn about your experiences and all that. So.
I think one thing I want to say, I don't know, just a life lesson. Something that I really realized is being open to new opportunities and not it's never too late to change something. You know, if something isn't working or an opportunity comes up that's a little different, you know, being open to that is really important, and taking chances, doing things that, you know, are out of your comfort zone. So that's kind of the best way to grow. And yeah, don't say, well, this is what I've always done, this is what I do, and just focus on that. You know, it's really important to kind of branch out and yeah, take opportunities, and just wanted to plug that.
Absolutely, that makes a lot of sense, and I think that's a very common sentiment I've heard from all the different like earlier guests that we have had, that they've all said that, yeah, be open to what's going to happen after grad school. Don't
Yeah,
pigeonhole yourself too much. Things will work out. Just give it the time to work themselves
Right.
out. So it's
it
fine.
will work out.
Yeah.
It will be
Exactly.
okay.
Yes. Uh, so before I ask my like final outro question, I still had one question, if you can discuss a little bit briefly about. So you brought up this topic of modeling maybe individual turbines and then also looking at these whole cluster of farms.
Hmm.
So I was wondering if there is like in your group right now, or even before at NREL, did you end up devising different kind of models to look at one singular turbine, and then that gives you some different kind of data that's important, and then you look at a flock of them? Because I assume that looking at a flock of them is computationally very expensive. So
Yes. Yeah. So again, it kind of depends on what you're looking for. So like when you're doing turbine design, that, which I don't design turbines. I just want to put that as a disclaimer. But that's typically like a single turbine, or at least initially you'll do a single turbine. And so there's lots of modeling that's done, kind of single turbine work that's done to look at different types of turbines. Yeah, turbine design, you know, kind of more not simple, but like control schemes, maybe you'll start with a single turbine and understand that. And then if it's something that would apply for a whole farm, then you would take a step up and do kind of multi-turbine modeling. A lot of times, especially for like mid-fidelity or high-fidelity coding, when we're looking at structures, don't do a whole wind farm. And so, sometimes the information that you need, you can get from modeling 2 turbines, 3 turbines, or kind of a 3x3, depending on if you're looking at different, wind directions or something like that. And so it's all about kind of what's the minimum level of effort you can do, but still getting the results that you need. And so, yeah, doing a full wind farm simulation with, detailed structures for every single turbine and a high fidelity wind, like
It's not happening.
I mean, that's like the goal, but it's not, it's certainly not the standard.
Right.
Um, yeah. And so, so it's just what's the minimum amount you can do. So yeah, if you're especially looking at structures, dynamic modeling, can we just do a subset of the farm? Will that get us what we want, or do we need to do the whole thing? So yeah, like everything, it depends.
It depends.
But yeah. Single turbine modeling definitely is incredibly important as well.
Got it.
Yeah.
Right. So I see that we are kind of nearing the end of our time, and thank you for sharing all the experiences and all of the things that you've learned along the way with everyone. The final question that I usually ask all our guests is that, and you've kind of touched on this already a little bit, so maybe some of it is just a repetition, but if you had any advice for current grad students, and specifically, I kind of distribute them or group them into 3 categories. So someone who is maybe just starting out, someone who's maybe somewhere midway in their program, and someone who is like about to graduate, they're in their final year, final semester. Any advice you have for them?
Let's see. I mean, yeah, everything I've already said. Oh, my camera just really unfocused. There we go.
You're good.
Yeah, I mean, everything I've already said. I think maybe I'll just reiterate, don't limit yourself in terms of opportunities. Don't maybe decide you want to do something and then just stick with it because you decided you were going to do it even though it's not working. Stubbornness. Very guilty of that. I think networking and getting out and meeting people, and this applies for every step of grad school and into your career as well, but I think networking is just one of the most important things you can do, and getting out and presenting at conferences and talking to people. And even if it's really uncomfortable, introducing yourself to people and building that network. That's something that I had to do at conferences. I was a side project. So I didn't get an in with anyone. And so like going out of your way and introducing yourself to people, even if that's really scary, especially like if you're introverted, I know that can be really hard. But just try it. It gets less scary the more that you do it. So just really, really try to do that. I think that's the best thing. I think doing stuff like Mega is awesome. I was in Mega when I was in grad school, and I met a lot of people through that, and just doing those sorts of things is really great for growing your network and learning about different areas. Go to the seminars. Even if it's not directly in your research area, go to the seminars, pay attention. It's all really interesting. And let's see, maybe thinking about someone who's maybe nearing graduation. Reach out to your network, like decide kind of what kind of job you want and reach out to people. Don't be afraid to tap into that network and email people. I think when I was in grad school, I was really afraid to email people and ask for their help. Like I was using NREL codes and I was really afraid to email folks from NREL and ask for their help, or, looking for an opportunity. Like, I don't know, I was like, I don't want to bother these people. These are really important people, and I don't want to bother them with my silly little grad student question. That's very silly. Email the people, email them, ask the questions. People want to help grad students. Like really, it's a really great part of kind of being out there is helping people who are coming up also. So email the people, ask the questions, ask for advice. If people don't email you back, that's okay, but they probably will, because people are more helpful than maybe you think. So yeah, that was my rambling answer.
No, that was great, and I think you covered a lot of the bases. Thank you very much. And uh, so yeah, if anybody is interested in wind research and CFD modeling, would you like to? Is there any way they can reach out to you? Your
Yeah, I'm on LinkedIn. That's probably the best way.
Okay, perfect. Yeah, I think that was everything that we had for today. Thank you very much, Dr. Kelsey Shaler, for making time for this out of your busy schedule and just joining us and sharing so many insights. Is there anything else that you would like to share with our audience that maybe Julie and I completely forgot to cover or talk about?
Uh, I don't think so.
All right. So everyone, thank you for joining us for this episode. You will have links to all of our different social media channels. You can join our LinkedIn alumni group as well. So kind of going off
I
of
should do that.
yeah, we have a LinkedIn alumni group. I can send you the link for that after we are done with this. So yeah, we can please feel free to join that, connect with some alumni who are there. Uh, and yeah, follow us for our next updates. If you're interested in some of the stuff that Mega is doing, please feel free to reach out. As you already heard a good endorsement from Dr. Shaler today, this stuff helps out. Join Mega, do some of these things, get out there, learn what other grad students are doing. It's fun. All right.